Example 2 for RC circuits under Kirchhoff Law. Based on Kirchhoff's law, R dq over dt plus q over c equals to et. Find the charge qt and the current at time t, it. If the resistance is 40 ohms, the capacitance is 0.01 farad. A battery gives a constant voltage of 200 volt and the initial charge is Q0 equals to 0. To solve this question, first we extract the given information, which is R, C, and ET. Alright, we write here R, C, and ET. Alright, from the given question, find the charge QT. Okay, so we can write QT equals to question mark. Okay, then we have current at time t, it. Okay, we want to find the charge QT and the current at time t, which is it. So we can write it equals to question mark, right? After that, we are given resistance is 40 ohms. Okay, this is R, right? So we can write R equals to 40 ohms. Okay, this is the symbol for ohms, right? Then we have capacitance is 0.01 farad. Okay, we can write C. Okay, so C equals to 0.01 farad. Okay. Next, we have voltage of 200 volts. Means this is ET. Okay, so we can write ET equals to 200 volts. Right? And the initial charge is Q0 equals to 0. Okay, this means when T equals to 0, Q, which is charge, equals to 0 coulomb. Okay, coulomb here means the unit for charge. Okay, this is the initial condition to find the value of C after we integrate, right? Because when we integrate using indefinite integral, we must put plus C at the back, and to find the value of C, we use this initial condition, right? After we extract R, C, and ET, so we can start with the given formula, which is R dq over dt plus q over c equals to et. Right? We substitute the values of R, C, and ET into this formula. Okay? So we got this. Okay? We replace R equals to 40. Okay? We replace C equals to 0.01. And we replace ET equals to 200. Alright? Right. Here means 1Q. Okay? This is 1Q. So 1 divided by 0.01 equals to 100Q. Okay? So we have 40 dq over dt plus 100Q equals to 200. Right? From here, we need to write coefficient of dq over dt equals to positive 1. So, what should we do? We need to dividing each term by 40. Okay, so after we dividing each term by 40, so we got this. Okay, dq over dt plus 100 divided by 40 equals to 2.5. And then we have q equals to 200 divided by 40 equals to 5. Right? From here, we can compare with the original linear equation under first order ODE, which is dy over dx plus bxy equals to qx. Right? When we compare, variable y means variable q, okay, which is charge, and variable x means variable t, which is time. Okay, and the most important part when we solve linear equation under first order ODE, we need to find integrating factor, which is IF. IF is given by e to the power of integration of px dx. Okay, when we compare, our px now equals to 2.5. Okay, so this is our pt actually. Okay, so to find IF, which is integrating factor for this linear equation, we can write IF equals to e to the power of integration of our px now equals to 2.5, and we integrate with respect to time. Okay, so it is equals to e, and after we integrate 2.5 with respect to time, we got 2.5 t, right? After we find integrating factor, we need to find the solution for y, for pure linear equation. But now we have q. Okay, so after we find IF, we need to find the general solution for q. Okay, so we can refer the general solution under linear equation. Y times IF equals to integration of QX times IF dx. Okay, in this case, our Q equals to Y. Okay, so we can write Q. Okay, our Y now equals to Q, so we can write Q times IF. IF equals to e to the power of 2.5t equals to integration of our qx now equals to 5. Okay, and then times IF. Our IF equals to e to the power of 2.5t. Then we integrate with respect to t. Okay, and then from left hand side here, there is no integration sign. So we still have q times q times e to the power of 2.5t, okay, for left hand side, and then equals to, we have constant 5 in front here, and then when we integrate e to the power of 2.5t dt, we got e to the power of 2.5t over 2.5. And since this is indefinite integral, so we must put plus c at the back, right? After that, we can simplify 5 divided by 2.5 here. Okay, so we got this. We still have q times e to the power of 2.5t on the left hand side, and then equals to, after we divided 5 by 2.5 here, we got 2, and then e to the power of 2.5t plus c. Okay, then we name as equation 1. Alright, from here we need to find c. Okay, so to find the value of c, we can use this initial condition. Okay, remember, when we integrate using indefinite integral, we must put c at the back. And to find the value of c, we can use the given initial condition. Okay, so we substitute t equals to 0, q equals to 0 into equation 1. T means time. Okay, means when time equals to 0, the charge q equals to 0. Okay, we substitute into equation 1, so we got this. Okay, q equals to 0, 0 times any value equals to 0, and then equals to 2e. After we substitute t 0 here, so we got e to the power of 0, and then plus c. E to the power of 0 equals to 1, so we got 0 equals to 2 plus c. Then we can solve for c. So we got c equals to negative 2, right? After that, we need to substitute the value of c into equation 1, right? After we substitute c equals to negative 2 into equation 1 here, so we got this, okay? Q times e to the power of 2.5t equals to 2e to the power of 2.5t minus 2, okay? After that, from here, we can find QT. Okay, we need to write Q as a subject. Means that we need to move e to the power of 2.5t to right hand side. Okay, since this is multiplication operation, so when we move e to the power of 2.5t to right hand side, it becomes dividing operation. Right? So we got this. Okay, Q as a subject equals to 2e to the power of 2.5t over e to the power of 2.5t minus 2 over e to the power of 2.5t. Right? So we can write the charge in the circuit at any time t is given by, okay, before that we can simplify e to the power of 2.5t from numerator and denominator like this. Okay? So our Q equals to 2 minus 2. Okay? In denominator here, we have e to the power of 2.5t. So under properties of indices, we can move up. After we move up, it becomes multiplication by e to the power of negative 2.5t. So this is our charge in the circuit at any time t, which is Q. Okay? The symbol for charge is Q. Okay? So our Q equals to 2 minus 2e to the power of negative 2.5t. Right? Next, we want to find IT. Okay? Means the current at any time t. Right? The current in the circuit at any time t is given by I equals to dq over dt. Means that to find the current for RC circuit, we need to differentiate the charge, which is Q, with respect to time. Right? So we need to differentiate Q equals to 2 minus 2e to the power of negative 2.5t with respect to t. Right? So from here, when we differentiate with respect to time, so we got this. Okay? We differentiate constant 2 equals to 0. And then we still have constant minus 2 in front here. And when we differentiate e to the power of negative 2.5t using exponential rule, we got negative 2.5 e to the power of negative 2.5t. Right? And then we simplify. So we got this. Okay? I equals to negative 2 times negative 2.5 equals to positive 5. And then e to the power of negative 2.5t. Right? This is the current at any time t. Okay? Because we have I in terms of variable t. Right? So these are the complete solution for this question. Right? Got it? Coming up next, Kirchhoff Law, more examples. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.